Well, hi there, boys and girls. Today we're going to take a look at the ratio test, which is going to be my choice of test whenever we're dealing with factorials. And here is the ratio test written out. So suppose we have a series, and we're going to take a look at the limit as n approaches infinity of a sub n plus 1 over a sub n. What this is this is the next term, and this is the next term divided by the previous term. So what we are doing is we are dividing any two terms together, and if this limit as n approaches infinity is less than 1, this series is absolutely convergent, which means it's going to behave sort of like a geometric series, because that's the same conclusion for a geometric series. If you have the common ratio of any two terms less than 1, it converges. And if that limit is greater than 1, the series is divergent. And if the limit is 1, it might be divergent, it might be conditionally convergent, we don't know. So the test fails if L equals 1, and you're going to have to pick a different test. So let's take a look at some examples. The first example I want to look at is, what about summation from 1 to infinity of n factorial squared over 2n factorial? And I want to find out whether this converges or not. Now, you can't use any of your previous tests because it's not geometric, it's not telescopic, so it's got factorials in it. And keep in mind that n factorial means n times n minus 1 times n minus 2 dot 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 all the way until you get to 1. And if you had even like n plus 1 factorial, that would mean n plus 1 times n minus 1 times n minus 2 all the way down till you got to 1. So I have factorials here, and I just said that the ratio test is my choice of test if I have factorials, so that's what I'm going to do. I'm going to find the limit as n approaches infinity of the absolute value of the next term divided by the previous term. Now the next term would be n plus 1 factorial, that's plugging in n plus 1 for n, times n plus 1 factorial. That's how we square something. We multiply it times itself. And on the bottom, if we replace n with n plus 1, you're going to get 2 times n plus 1 factorial. And I'm going to divide this by the previous term. Now, the way you divide fractions you learned in 7th grade is you flip it over and multiply. So I'm going to multiply by the reciprocal of this. This is the previous term, 2n factorial over n factorial squared. And I'm going to compute this limit. And let's see what happens here. Well, first of all, n plus 1 factorial means this up here, n plus 1 times n minus 1 times n minus 2. And it matches n factorial, except for it has the extra factor of n plus 1. You notice how these are pretty much the same, so they're the same after n plus 1 factorial. So if I were to divide these two, I would cancel everything but n plus 1. So let's take a look at how that works. The limit as n approaches infinity of. Now, n plus 1 factorial divided by n factorial. Take a look at this again. If you divide n plus 1 factorial, you're going to get n plus 1 times n minus 1 dot dot dot. That's n plus 1 factorial. And if you divide that by n factorial, that's n times n minus 1 times dot dot dot. Those cancel, everything's going to cancel except for the n plus 1. So the n plus 1 factorial divided by one of these n factorials is n plus 1. I'm going to do the same thing for the other one. N plus 1 factorial divided by n factorial is just n plus 1. So I've taken care of those. Now what about the 2 times n plus 1 factorial? Let's take a look at that before we decide what that is. I'm going to distribute the 2, and that's going to be 2n plus 2 factorial, which means 2n plus 2 times 2n plus 1 times 2n times 2n minus 1 dot dot dot. That's what 2n plus 1 factorial will be. Now 2n factorial is simply 2n times 2n minus 1 times 2n minus 2 dot dot dot. You'll notice that once you get to the 2n, those things start to cancel, and we're left with just this. So if I'm simplifying 2n factorial over 2n plus 1 factorial, I am going to get, well, simply 2n plus 2 and 2n plus 1, but once I get down to 2n, it cancels all of those. So this is the limit that I want to compute. Now, if we were to multiply everything out here, you would get an n squared plus, well, 2n plus 1. But if you multiply the top out, you're going to get an n squared as like the leading, the first term, the leading coefficient would be 1. And if you multiply the bottom all out, you would get a 4n squared. You'd get some other stuff, but when we're taking the limit as n approaches infinity, remember, we just look at the highest degree on the top and bottom. Then we play that game, you know, if it's bottom heavy or top heavy, or if they match. Now here they match because they're both n squareds, and the ratio of the coefficients is 1/4. Now what did I get? I got a number that was smaller than 1. That means that this series right here is a convergent series. So the series converges. Now that was some pretty intense look at factorials, but you need to get used to that. Let's take a look at another example. What about the series from 1 to infinity of, how about n factorial over 4 to the n? So I'm going to put a factorial over an exponential. I've got a factorial in it, so I'm going to use the ratio test. I'm going to compute the limit as n approaches infinity of the next term divided by the previous term. The next term is n plus 1 factorial divided by 4 to the n plus 1. All you do is replace your n's with n plus 1. And then you're going to divide by the previous term, which is the same thing as multiplying by the reciprocal. So let's take a look at what happens here. Let's take a look at our factorials first. Wouldn't hurt to see this again. N plus 1 factorial. And we're going to divide that by n factorial. This means n plus 1 times n minus 1 times n minus 2. And we're going to keep multiplying until we get to 1. Now n factorial means n times n minus 1 times n minus 2 times ... until you get to 1. What happens? Well, those cancel, those cancel, those cancel. All of this stuff is going to cancel, except for you'll be left with an n plus 1 in the top. So n plus 1 factorial divided by n factorial leaves me an n plus 1. Now let's take a look at the exponentials. 4 to the n over 4 to the n plus 1. Well, you know that 4 to the n plus 1 with our practice with geometric series can be rewritten as 4 to the n times 4 to the first. That's 4 to the n plus 1. The 4 to the n's cancel, and we're left with just a 4 on the bottom. And I want to compute this limit. Now this fraction happens to be top heavy. There's no n on the bottom at all. And a top heavy limit is going to approach infinity. This does not have a horizontal asymptote. Now infinity happens to be a little bit bigger than 1, which means from our ratio test, if it's bigger than 1, the series is divergent. So this is a divergent series. And I've talked to you guys about the fact that the factorial is going to outgrow any exponential, any polynomial. If it's on top, that's just going to be a divergent series. But now we have a way of proving it. So there you go. That's the ratio test, and I will see you guys tomorrow.